The first speaker is Stefan Schmidt. I asked to come to the stage. He's a passionate software developer, did a lot of Linux projects, and he is, after many years of freelancer, working in the Huawei open source technology centers. And he's going to present the release 2 of the Oniro project. Please.
Thank you. So if you look at the picture, you can see that's not me. So that's my boss. He's not able to come here. So if you're looking for any charming, charismatic Italian speaker, sorry to tell you, it's not coming, it's me. Anyway, so we had Oniro. We had it last year already. Last year we have been here presenting about what Oniro is, what we are doing, and this time we want to present about the release that's imminent right now. So right now we're actually working on the last merge request to get that done, and hopefully within the next few weeks we are calling it a full release 2.0. So I want to talk a little bit about what we've been doing this year, the full year. So Oniro is designed to be a full production grade open source. So it's not only meant to like toy around with, but really meant for like companies to build on top. So it's an Eclipse Foundation project. We have like 9 members right now. We launched at SFScon22. That's the official launch. We worked on that before on the project, but then we launched it within the Eclipse Foundation. It's for devices big and small, the OS here, so it's not a new OS or anything, so that's something people often confuse. So we're still using Linux, we're using Zephyr, so the kernels are already something that exists. We only take them and make them work for us in a better scale. We have opinionated defaults. That means we have like ideas how we want to run the system, how we want to build the platform. This is something that we provide that can be changed if you're a device manufacturer or something. You can change these things, but that's something we want to bring up, and not only a collection of libraries that everybody can put together. We build a full system basically. And for that, we have like continuous integration, deployment, validation, compliance, all the other things that are running all the time to make sure that we build something and test it all the time that is really workable. Yeah, we have SBOM, we have VNV reports, all kind of artifacts. I have to be a bit quick here because my boss put in a lot of slides. And obviously, we also have like bug and CVE policies and service level agreements for maintenance and long-term maintenance. So we are market-driven. That means when we started, we looked at the market, we talked to partners, we gathered the requirements from them, and then from there distilled what we thought was like a good baseline to start off and go ahead and build a platform for people to work on. The 20-80 rule, so we try to deliver like 80% of the stuff, and then the rest you can do like 20% you can do on your own, but it will cost you 80% of the time. So we still at least want to give you something you built on top of, but yeah. So again, integration, opinionated defaults, and documenting, compliance, all these things would be there. You can start with, and then do your own application or integration or building for a specific hardware or whatever you want to do. And we also have the infrastructure, so we're running on GitLab. We're having all the CI pipelines set up there, making sure that everything runs smoothly. Also having a compliance toolchain that is also running in the background, also tied up with our CI and so on. So let's go down the rabbit hole here for 2.0. What did we do the last year? So Bitbake, this is our tool to knit all the things together. That is the heart of the Yocto project, basically. So Yocto has this approach of different layers. I come to that later. So it basically takes all the pieces and integration parts, but also like code and information to get it all together, build it, and then in the end there comes a final image you can put on your device and then run with it. It's a broad collection of libraries, it's Linux and so on. There's also the Linaro Ledge project, which also had a lot of information, and they are providing that in terms of Yocto layers that we can integrate and we are using as well. For hardware scalability, and in general, as I mentioned, there's the layered architecture, and you can see here how that looks like. So if you have a checkout of the Oniro build and want to get started, you can see all these different folders here. And these are for the main build system, like Bitbake. They're also like the Oniro receipts, so all the things we are adding on top, and like how we modifying the existing libraries with our default settings and making sure that everything runs smoothly together. But in general, the big amount of code we are using here is from other open source platforms. So we're really doing a lot of integration work here. So it's coming from the Open Embedded project, which is part of the Yocto project, basically. Then there's the Linux kernel. On the smaller side, there's the Zephyr kernel, and so on. We have the hardware support for all of these. We have documentation, IP policy, and again, Zephyr FreeRTOS is something we have like experimental support for. That's another RTOS system, but it's not really developed much. It really depends on a partner or some interested party coming in and want to join and help. We're also working on an OTA delivery system, so that's something that is a bit more unique, and that's something we develop within Oniro, how we want to handle that for like the bigger devices, for the smaller devices, and so on. And OpenHarmony, that's another component we are putting in there, but I have another slide deck on that. So devices big and small, the way we are doing that, the way we are exposing and designing that in Oniro is with flavors. So when you set up your workspace, you give a flavor for either Linux or Zephyr at the moment, or you can go with FreeRTOS or LightOS or something, and that would do all the setup for you to have the correct toolchain, to have like the correct settings. Then you can select the machine depending on what you want to do, what you want to support. It could be a virtual machine like a QMO, or it could be a hardware device or something like that. So we have some supported, but due to the Yocto layers and so on, it's very easy to bring in other boards and your own BSPs and your own hardware support basically. So we have support for Linux 5.10 with Cortex-A devices, Intel RISC-V. We have Zephyr 3.1. Again, it's a Linux Foundation project. That's mostly for the smaller devices, Cortex-M-based, MCU, microcontroller-based systems. Again, FreeRTOS experimental, I mentioned that. And LightOS is something that comes from the Huawei side. That's another RTOS that's developed in Huawei. It's really popular in China. So that's something we also have like experimental support within the Meta OpenHarmony addition to Oniro. Basically, that's what I brought up here. So we have different hardware support already. We have also QMO support for virtual development, which is really nice and for just your normal development on a laptop or something like that. Raspberry Pi, very, very popular device. We have the support Raspberry Pi 4 in 64-bit mode, but also other Pis could be interesting for others to play around with. And then Zephyr, that's a board from Arduino we are using there. Yeah. Okay, so what else did we do? We don't only do hardware support and integration, but we also do new stuff. And so we have interoperability, connectivity. So there's the Project Meta, which was it's a language for the IoT devices, which was released, like I think they released it in September, October timeframe, 1.0. There's a spec and an SDK for that. We integrated that, so we have a possibility to like use that with other devices out there. We have OpenThread, which is a low power communication protocol, a wireless communication protocol for a mesh network where you can really run small devices on a coin cell battery for a year, for example. So if you have like a sensor or something, you still have wireless communication back to bigger devices, which is quite interesting. OpenHarmony, I mentioned that it's a full stack of like software that can run either on your mobile or an IoT device. It's developed by Huawei, also again popular on the Chinese market. So that's something we have as an add-on. So we can bring that in as a different layer, and you can build it in based on the Oniro platform. Podman, that's something we're using for containers. You basically can run your Docker containers. Podman is just a bit more secure here, how you can like run rootless and stuff like that. But so we have a story to like deploy your applications and everything based on Oniro. You can do that as a container deployment if you want. Modbus for industrial IoT, it's just another supported connectivity we're having. And LVGL Flutter, that is like our idea so far for like UI and UX, what you can do. LVGL is something natively, you can run that on Zephyr as well as Linux, and Flutter is, that's more like something you can also run on Android devices and so on. So on SysOTA, that's the OTA platform we are developing to really bring over-the-air updates to all the devices you're having. So OpenHarmony, this is packaged in a way that it's another layer. So I mentioned that before in Yocto, you have all these different layers you can put together. It's a really nice way of like being modular and really targeting the ideas and use case you're having. And if you want to support OpenHarmony, you would add the additional layer here, and then you get support for that. So we're doing an IP analysis on all the codes going on. That's ongoing right now. We're hoping to finish that towards the end of the year. And once you include that into your layers, then you can be OpenHarmony compatible. So that might be interesting for people that want to ship their devices to be OpenHarmony compatible. You can do that with running this add-on. And then you have like support for extra things, cameras and screen incorporation, and a few other things that OpenHarmony brings into the play here. So Eddie, I gave a talk about that this morning at 11:20, so I will really brief on that. It's working. It's an idea to have like a distributed device agency, so you have an understanding. You have like a unified pool of resources in your network, in the distributed network, and then they can be used together to make like make intelligent decisions, decision-based process. That's a research project we are doing with the Politecnico di Milano, and that's ongoing. So we have like part of that is already implemented on Linux and Zephyr. We have the communication, the virtualization layers done so far. It's based on CoAP, which is a constrained application protocol for a resource directory. And we have a demo for that. If you look at the Eclipse booth out there, we have a demo that is showing a door lock and a smart touchscreen that's actually using Eddie as a background for the communication part. Whew, okay, so we have, it's a lot of slides, I told you. For the companies that want to use this project, it's also quite interested in not only have the technology, but also all the stuff around it. So if you have a compliance envelope, you have verification, validation, and so on. This is something we want to keep ongoing in a continuous manner. So we have like the OpenChain and OpenSSF. We are working with them, trying to implement all the guidelines they are giving and being compliant with that. We have a continuous license compatibility, so we have a dashboard for that to see what kind of new code comes in, what license it has, like it needs to be audited, then we can generate an SBOM out of that. And then we have Lava, which is a testing framework coming from the Linaro side. That means that every build we are doing, every merge request that comes in, it gets built and then actually executed on real hardware in some test lab, and we make sure that everything, at least the smoke testing, is working. So that's quite a lot of things going on. One of these test labs is actually right now being prepared here in Neutech Park. So Neutech Park is a partner of the project, so that's like one of the things they are doing. So our IP team rocks. So not only have like a rock star in there, there we go, but we also have like, they're doing a lot of work. So they have like, in the release, we have like 4 million source files audited within 9 months. So they really have to look at all these things, making sure that the license is fine, that they don't have like any problems with that. So going on that, we have like a really big coverage already, 89%. We have like around 100 issues that have been identified in open source projects or in different components, and then reported them back to upstream. We told them, okay, there's something wrong, your license looks odd, or you have like binary files in there, you have a proprietary font or something like that. So we reported it back, worked with them to get it fixed, and then backported in our. So that's like part of our duty to make sure that we also bring it back to the open source projects. We have a lot of things, so we're using scan code and pathology improvements to like have our pipeline running well. That's something we are working on as well. And there's more work ongoing for deeper integration. So, okay. Again, verification and validation results integrate into the process. We want to have a test plan 100%. That's always the goal. And now we have like, right now we are covering like 80% of our release epics. That's the requirements we are having, and having an 85% pass rate. The Lava loads, as I said, they're running and they do the automated testing. And we have a bug triage process and really trying to like get all the bug fixed and have like a SLA for like all the maintenance and long-term support and so on. Checkbox integration, okay. So system OTA, that's our OTA solution based on Hawkbit on the server side. So you can do like deployment of all the big updates you're having. And then you have a RAUC integration. RAUC is another open source component we just took and then put some stuff on top of it. That's this OTA. And we're working with Hawkbit. But we also have support for something called NetOTA, which is a really small version where you can just have like a hosted server where you have like your updates, and then you can pull from it instead of having like a complete deployment with Hawkbit, which might be a bit complicated for like small setups. And with that, I have 50 seconds left. Thank you, and questions.
Thank you, Stefan Schmidt.
Okay.
You have been perfectly in time. So, where are the Oniro developers? What are your questions?
Can you describe how BitBake is like a sausage factory?
No, I can't. You have to ask my boss about that. I mean, the idea is basically that BitBake is a tool that pulls it all together, right? It's like you have this layered approach where you have like all the flexibility of the world. It comes with some pain as well, don't get me wrong, but you have all these possibilities you can do, and that's like a sausage is made by like taking all the ingredients, mashing it together basically, and then putting it together and getting something out, right? And that's what we do. We get all the ingredients, putting it, merging it, and then getting an image out and something to deploy.